In this question, we want to draw shear force diagram and bending moment diagram using theorem of three moments. In this case, we have a fixed supported A, a roller supported B, a roller supported C, and D is a free end. So segment CD is overhang. Now first thing that we need to do to solve questions using theorem of three moments is to draw corresponding simply supported spans for all the supported spans, and we will leave this overhang part in that as it is. So here I have the corresponding simply supported spans A, B and B, C, and as there is no load on spans A, B and B, C, there will be no loads on corresponding simply supported spans, and because of that the bending moment diagrams for both AB and BC will be 0 everywhere. The bending moment at the support just before overhang, that is support C in this case, can be found by considering free body diagram of overhang CD. And if I write sum of all the moments about C equals to 0 by considering clockwise as positive moments, so this will give me the moment because of this MC, which is clockwise, will be plus MC. The moment because of this vertical force will be 0 because it passes through the point C. The moment because of this W will be clockwise, so plus W into lever arm is L by 2, so into L by 2 equals to 0. So this gives me MC equals to minus WL by 2. Also note that at A we have a fixed support, so we add an imaginary span on the other side of the fixed support. Let's call this A dash, and the values of all the parameters for this imaginary span will be 0. Let's call this L0, that will be 0. The bending moment diagram will also be 0 everywhere. So now we can apply theorem of three moments on this beam. Here MA dash will be 0. So let's write the theorem of three moment for span A dash A B. MA dash is 0 plus 2MA. L0 is 0 plus L1 is capital L plus MB. And note MB will not be 0 because it is bending moment at interior roller support, into L1 is capital L equals to minus 6 into A0 x0 L bar will be 0 because everything for the imaginary span is 0, plus A1 x1 R bar will also be 0 because bending moment diagram for span AB is 0. So this gives me 2MAL plus MBL equals to 0, or 2MA plus MB equals to 0. Similarly, I can write theorem of three moment for spans A, B and C. So here I will get MA into L plus 2MB into L1 is L plus L2 is also L plus MC is minus WL by 2 into L2 is L equals to minus 6. And because the bending moment diagram for corresponding simply supported spans AB and BC is 0, so I'll get just 0 plus 0 on the right hand side. So this gives me MAL plus 4MBL minus WL squared by 2 equals to 0. Here I can take one L common, so I'm left with MA plus 4MB equals to WL by 2. Let's call this equation 1 and this equation 2. So I can substitute value of MB from equation 1 into equation 2. So this gives me MB equals to minus 2MA. This I can substitute in place of MB. So I get, so this gives me minus 7MA equals to WL by 2. This gives me MA equals to minus WL by 14. MB is minus 2MA. So that becomes WL by 7. And MC we already know is minus WL by 2. So now I know values of all the bending moments at the ends of the segments. So here I have shown all the beam segments with their bending moments at the ends. Here MA is minus WL by 14. So I have shown that as plus WL by 14 in hogging sense. MB is WL by 7. So I have shown that as sagging WL by 7. MC is minus WL by 2. So I have shown that as plus WL by 2 in hogging sense. Now we can find end shears at the ends of all the beam segments using equilibrium equations and then draw the bending moment and shear force diagram using the method followed in previous example, and you can see my video of previous example to do that.